Okay, in this section, we're going the other way. In the first section, we were given the type of things we needed to input in a function, and we found the corresponding outputs. In this section, we go backwards, which is something you're also very often going to be asked to do in this class, in calculus, and everything afterwards. What happens if they give us the output and asked us to find the input? The first thing of the list of things they asked us to do is they say, solve g of x equals 7. That is, find the x value that we need to plug in so we get 7 for an answer. Well, all that should mean is we write down g of x we write equals 7. Just a reminder what we normally do under those situations to solve that kind of thing. We put a little 1 here and then we cross multiply. So I'm going to get 14x plus 21 equals 5x plus 1, like that. I think I'm going to throw the 5x over here, subtracting 5x from both sides. I'll get 9x over here. And then subtracting 21 from both sides, I'll get negative 20 over here. And then dividing both sides by 9, I'll get x equals minus 20 ninths. And that is the correct x value that we need to plug into here in order to get 7. You should try just plugging this back in here and making sure you do. That would be practicing inputting. Or to check, you could put this function in at Desmos and then just put this number in and make sure you get 7. So there we do have several ways to check. All right, that's the first thing they asked us to do, is find the x values so that the output was 7. The second thing they asked us to do, and this is very, very common, is solve. In other words, find the correct input so that g of x equals 0. Now we're going to solve this the way that they normally do this in contexts after this. Now we could see that we could cross multiply, but the thing that you really need to remember is that a fraction is 0 only when the top is 0. So all I'm going to do is set the top equal to 0. Now in this particular example, that's the same thing I would get if I were to cross multiply, but there are times when you only want to set the top equal to 0 and there's not a whole lot to cross multiply. Anyways, I set the top equal to 0, I subtract 1 from both sides, I divide by 5, I get x equals minus 1/5, and that is the correct number to plug back into g of x, so they get a 0 on top and not a 0 on bottom. So that's the second kind of output that very often we're going to be asked to find. The third one is also very, very common, and we'll talk about why it's common, but we'll try it first. They want solve g of x equals 5/2. So what we're going to do is just set g of x equal to 5/2 and see what we can do. So I'm going to get 5x plus 1 over 2x plus 3 equals 5/2. We can cross multiply with this one. So I'm going to get 2 times 5x plus 1 equals 5 times 2x plus 3. I will expand both sides. I'll get 10x plus 2 equals 10x plus 15. Now we can see that we can subtract 10x from both sides. So let's subtract 10x from both sides. And we get 2 equals 15, which is ridiculous. Actually, in math, they tend to say that's absurd. What does that mean? We started out by writing, supposing we could find an x such that g of x equals 5/2. Well, if that's possible, we come to the conclusion that 2 must be equal to 15, which is ridiculous. Now, what does this mean? This means it's actually not possible to solve the equation gx equals 5 halves. And let's just write this down and say this equation has no solutions. And we're going to use the shorthand for solutions that you'll see very, very often this semester. All right, so there are 3 kinds of outputs. Just a regular output where we could solve for x, a regular output where we could get 0 and we use a special thing by only setting the top equal to 0, and the third kind of output where it wasn't even possible to get that output. Those are the 3 main ones you're going to see a lot, so those are the things we have to practice.